A single phase bridge inverter is shown in the figure consisting of 4 transistors and 4 feedback diodes. When Q1 and Q2 are turned on, input supply Vs is going to flow through the load. Then the path will be, let it be X and Y points. Then the path of the current will be X through Q1 to the load to Q2 to Y. When Q3, Q4 are turned on, then the path will be X to Q3 to the load to Q4 to Y. But when you observe with respect to the load, here the current path is from A to B. Here the current path will be from B to A. If this is giving Vs with respect to the load, this will give us the minus Vs with respect to load. This is how a single phase bridge inverter works. Then the waveforms you can observe between 0 to t by 2, the Vs is going to appear across the load. At t by 2, Q3, Q4 is turned on, so negative Vs is going to appear across the load up to t. Thereafter again Q1 and Q2. So this is Q1, Q2, and this is Q3, Q4, again Q1, Q2. Done. The fundamental current I will be Vs by the load resistance. So this is I naught, the fundamental current in case of the resistive load. Now the RMS output voltage can be found by using the formula V naught equals to 2 by T integral 0 to T by 2 Vs square dt whole to the power of 1 by 2. To calculate this, you are going to get V naught equals to Vs. Let it be equation number 1. This is an RMS voltage. Now the instantaneous voltage from the Fourier series, as we seen in the half bridge circuit, V naught equals to sigma n 1, 3, 5 and so on to infinity 4 Vs divided by n pi sine n omega t. Let this be equation number 2. For n equals to 1, the RMS value of fundamental component is given by the V1 equals to 4 Vs divided by pi of root 2. This will be 0.90 Vs. Let it be question number 3. The instantaneous load current I naught in case of RL load equals to sigma n equals to 1, 3, 5 and so on to infinity 4 Vs divided by n pi under the square root r square plus omega L whole square n square multiplied by sine n omega t minus theta n. This is equation number 4, where theta n equals to tan inverse of n omega L by R. When transistors are off, then the diodes is going to conduct the D1 and the D2. Then the energy is fed back to the DC source, as they are known as feedback diodes. Similarly, when D3 and D4 conducts. These are the waveforms for load current with highly inductive load. If this video is useful, please like, share and subscribe.